Okay, so we worked with that question there, which is quite reminiscent of a GCSE higher tier probability question. And we're going to introduce a new bit of notation for you now, because as I've highlighted there, when you've got a situation where you've got something that is without replacement, so once that first shoe has been taken out, what happens in the second set of branches is conditional on what's already occurred in the first event. So the first event here was the first shoe being drawn. As soon as that happened, because it wasn't put back in the box, there are only 13 shoes left in the box. So the denominator in this second event is now out of 13 rather than 14, and each probability on the branch is dependent, conditional on what's already occurred. So that outcome there, the probability that the second shoe is left, has got a smaller denominator because there's only 13 shoes left in the bag, in the trunk, and in this case, because the first shoe was left, there's one fewer left shoe in the trunk. So rather than being at 7, you've got 6 as the numerator. So the outcome is conditional on the first. And as I've put in the sentence here, in general, for two events A and B, the probability of B occurring, given that A has already occurred, is written as probability B and then a vertical line A. So that would be what we've got there, would be the probability left, given that left has already happened. So the line you would read as given that. So that would be read out as probability of B occurring given that A has already occurred. Okay, so probability B given A. Probability of B occurring given that A has already happened. And if we generalize that on a tree diagram, so if I have here event A and event not A, then that's the probability of A occurring. That's the probability of A not occurring. And then if we have the second event B, B is going to occur or it's not going to occur. B is going to occur or it's not going to occur. So this probability here is the probability that B occurs given A has already occurred. So that's going to be probability of B given A. This one will be the probability of B not occurring given that A has already occurred. This one here would be the probability of B occurring given A didn't. And this one would be the probability of B not occurring given A hasn't occurred. So we're familiar with writing that straight down, but now I've introduced a notation for that. It's an important notation to get familiar with. Now, using our rules of moving along a probability tree diagram, we also know that if we get to this point, we've moved along probability of A and that one. So that would be the probability of A and B. And to get to the probability of A and B occurring, what we're doing is we're multiplying the probability of A by the probability of B given A. So the probability of A and B is the probability of A multiplied by the probability of B given A has occurred. This one would be the probability of A and not B, which would be the probability of A multiplied by the probability of not B given A. And I've just put a little slant to that. It's not a fraction, that should be vertical, that's me being bad. This one, probability of not A and B, will be the probability of not A multiplied by the probability of B given not A has already occurred. And finally, the probability of not A and not B will be the probability of not A multiplied by the probability of not B given not A. And this leads us then to the generalization, which we'll look at before the next couple of examples. So this leads to the conditional probability formula for dependent events. So I've written it in green because you're given it in the formula book. Okay, so that's the way this is provided to you in the formula book. Probability of A and B, so it's basically a copy of that top line there. So the probability of A and B is the probability of A multiplied, by the probability of B given A has occurred. But we tend to write it more readily in this form. So if I want to find the probability that B occurs given A already has, then it's the probability of A and B occurring divided by the probability of A. So predominantly you've got your two letters, on top of that the intersection of the two, so A and B or B and A, doesn't matter, they'll be the same. But then the fraction at the bottom is the given that. So it's there. So if you wrote it the other way around, if that was A given B, the top would be the same, but the bottom would be the probability of B. So it's important that you identify when you're working with a conditional probability event. This will be combined with the rules from last week, which were the probability of A union B, or A or B, equals probability of A plus probability of B minus the intersection. So we've got that one. We've got the test for independence, which is probability of A and B is probability of A multiplied by probability of B. So we covered those last week and you did those at AS. So this is the first piece of new knowledge that you need to manage with the A2 probability. So let's have a go at a couple of examples.